The screens went dark at precisely 11:47 p.m. Eastern Standard Time. Not just one screen, not just one department, but every single monitor, display, and interface across the entire Johnson Space Center complex in Houston, Texas. The hum of thousands of computers, the constant chatter of mission control, the rhythmic beeping of telemetry data, all of it ceased in an instant, replaced by an eerie, suffocating silence that no one who was there that night will ever forget. Outside, the parking lot still glowed under sodium vapor lights. Security guards continued their rounds, unaware that inside, the nerve center of American space exploration had just experienced what would later be described as a complete systems failure. But this wasn't a technical malfunction. This wasn't a power outage or a cyber attack. This was a decision, a deliberate shutdown ordered from the highest levels of NASA administration. And the reason for this unprecedented action was currently hurtling through space at nearly 40 kilometers per second. On a collision course with the planet Mars. The object had a designation that sounded more like a catalog number than a harbinger of cosmic significance. 3I, Atlas. That small letter I in the designation told astronomers everything they needed to know, and simultaneously filled them with an excitement that bordered on obsession. The I stood for interstellar. This wasn't a comet from our solar system, not a chunk of ice and rock that had been orbiting our sun for billions of years. This was a visitor from beyond, a traveler from the vast darkness between the stars. Only the third confirmed interstellar object ever detected entering our solar system, and the first one that was headed toward a direct encounter with another planet. To understand how we arrived at this moment, how NASA found itself in a position so unprecedented that it required a complete shutdown of operations, we need to go back exactly 7 months, 13 days, and 6 hours before those screens went dark. We need to go back to a cold morning at the Haleakala Observatory in Hawaii, where an automated telescope system called Atlas, the Asteroid Terrestrial Impact Last Alert System, captured something unusual in the pre-dawn sky. The Atlas system wasn't looking for interstellar objects that morning. Its job, its entire purpose for existence, was to scan the heavens for asteroids that might pose a threat to Earth, to give humanity as much warning as possible if a cosmic collision was heading our way. But what it found instead would prove to be far more intriguing and, in ways that no one could have predicted, far more consequential. The initial detection was unremarkable to the automated systems, just another moving point of light, flagged by the software, added to the database of objects requiring follow-up observation. But when the human astronomers began analyzing the data later that morning, they noticed something odd. The object was moving fast, far faster than a typical asteroid or comet. Its trajectory was all wrong. The orbital calculations weren't making sense. And when they tried to backtrack its path, to determine where it had come from, the computer models kept producing impossible results. The object wasn't following an elliptical orbit around the sun like every other comet and asteroid we'd ever observed. Its trajectory was hyperbolic, which meant it had come from outside our solar system and had enough velocity that it wouldn't be captured by the sun's gravity. It would pass through our neighborhood and disappear back into interstellar space, a brief visitor from the cosmic ocean beyond, within hours. Observatories around the world were redirecting their instruments to confirm the discovery. The Gemini Observatory in Hawaii, the European Southern Observatory in Chile, the Cala Alto Observatory in Spain, all of them locked onto this mysterious traveler and began gathering data. Spectrographic analysis revealed a composition unlike anything we'd seen before. This wasn't just unusual. This was alien in the most literal sense of the word. The light reflecting off the object showed chemical signatures that didn't match the profile of solar system comets. There were compounds present that suggested this thing had formed in a radically different stellar environment, around a star with a different composition than our Sun. In a planetary system unimaginably far away, the astronomical community erupted with excitement. Papers were rushed into publication, press conferences were held, and the object was given its official designation, 3I Atlas, the third confirmed interstellar object discovered by the Atlas system. The first had been Oumuamua in 2017, that bizarre cigar-shaped object that tumbled through the inner solar system and sparked endless speculation about its true nature. The second was Comet Borisov in 2019, a more conventional-looking comet, but one that clearly came from beyond our solar system. Now we had a third, and this one was special because of where it was going, unlike Oumuamua, which passed relatively close to the Sun and Earth before escaping our solar system, and unlike Borisov, which passed through the outer solar system. 3I Atlas had a trajectory that would take it on a close encounter with Mars, not just near Mars, but terrifyingly close. The preliminary orbital calculations suggested it might pass within 50,000 kilometers of the Martian surface. To put that in perspective, that's closer than many of our satellites orbit Earth. This was going to be the first time in recorded history that humanity would be able to observe an interstellar object having a close encounter with another planet. Every space agency on Earth immediately recognized the scientific value of this event. This was unprecedented. This was the opportunity of a lifetime, maybe the opportunity of a century. NASA already had 5 active missions at Mars. The Perseverance rover was exploring Jezero crater, collecting samples that would one day be returned to Earth. The Curiosity rover was still going strong in Gale crater, even after more than a decade on the Martian surface. The InSight lander was listening to Marsquakes, probing the internal structure of the planet, and orbiting high above were the Mars Reconnaissance Orbiter and the Maven spacecraft, studying the planet's surface and atmosphere from space. Suddenly, all of these missions had a new priority. They were going to witness something no human-made instrument had ever seen before, an interstellar object screaming past another world at cosmic velocities. The initial enthusiasm at NASA was palpable. Teams were reorganized, observation plans were drafted, and instruments were recalibrated. The Mars Reconnaissance Orbiters, powerful cameras, designed to photograph the Martian surface in stunning detail, would be turned toward space to capture images of 3I Atlas as it approached. Maven's instruments, normally studying how Mars loses its atmosphere to space, would be retasked to measure any effects the comet's passage might have on the Martian magnetosphere and upper atmosphere. The rovers, while unable to see the object directly, would monitor for any unusual changes in atmospheric conditions, radiation levels, or even seismic activity if the encounter was close enough to gravitationally stress the Martian crust. But as the months passed, and more observatories tracked 3I Atlas, as more data poured in and the orbital calculations became more refined, the excitement began to mix with something else. Concern, then worry, then something approaching fear. The trajectory was becoming clearer, and it was closer than anyone had initially thought. Much closer. The 50,000-kilometer estimate was revised downward. 40,000 kilometers. 30,000. 20,000. With each refinement, each new batch of observations, the projected closest approach distance shrank. Teams of orbital dynamicists worked around the clock, running simulation after simulation, checking and rechecking their mathematics, hoping to find an error that would give Mars a wider berth. But the numbers didn't lie. 3I, Atlas was going to pass within 15,000 kilometers of the Martian surface. At 15,000 kilometers, this was no longer just a close encounter. This was an extremely close encounter. At that distance, the gravity of Mars would significantly alter the comet's trajectory. The comet's gravity, while much weaker, would also have measurable effects on Mars. And if 3I Atlas was actively out, if it was releasing jets of gas and dust like a typical comet as it warmed from its approach to the inner solar system, then there was a real possibility that Mars would pass through the comet's coma, the vast cloud of gas and dust that surrounds a comet's nucleus. The scientific opportunities were staggering, but so were the risks to the spacecraft. Engineers began running risk assessments. What would happen to the Mars Reconnaissance Orbiter if it was hit by debris from the comet's tail? The spacecraft was designed to handle the occasional impact from micrometeorites, tiny grains of dust traveling at high velocity. But a comet's debris could be larger, more numerous, and moving at even higher relative velocities. A single impact from a grain of sand hitting at dozens of kilometers per second could punch through solar panels, damage instruments, or even catastrophically compromise the spacecraft's structure. The Mars Reconnaissance Orbiter alone had cost over $700 million to build and launch, and it had been operating at Mars for nearly 2 decades. Losing it would be a devastating blow to Mars science. The rovers presented a different kind of concern. On the surface, they would be protected from most of the comet's debris by Mars's atmosphere. Even the thin Martian atmosphere, just 1% the density of Earth's, would be enough to burn up smaller particles before they reached the ground. But there were other risks. If the comet's close passage generated powerful electric currents in Mars's ionosphere, it could create electromagnetic interference that might damage the rover's sensitive electronics. And there was a more exotic possibility that some scientists were beginning to whisper about. What if the gravitational stress from the close encounter triggered Mars is not a tectonically active planet like Earth, but it does experience quakes. InSight had detected hundreds of them. If a large enough Marsquake occurred in the wrong place at the wrong time, it could topple one of the rovers or damage the landers. But these operational risks, as serious as they were, paled in comparison to what the scientists discovered when they got their first really good look at 3I Atlas itself. Up until this point, most observations had been focused on tracking the object's trajectory, nailing down exactly when and how close it would pass Mars. But as 3I Atlas drew closer to the inner solar system, as it brightened and became easier to observe, astronomers began studying the object itself in greater detail, and what they found defied explanation. The Hubble Space Telescope was granted emergency observation time, bumping other scheduled observations to capture detailed images of 3I Atlas. When those images came down and were processed, the scientists gathered around the monitors fell silent. They had expected to see a comet, probably an irregular chunk of ice and rock, maybe a few kilometers across, with a fuzzy coma of gas and dust surrounding it. What they saw instead was something else entirely. The object was larger than expected, much larger, estimated at nearly 20 kilometers in diameter. But it wasn't the size that shocked them. It was the shape. 3I Atlas wasn't round. It wasn't irregularly potato-shaped like most asteroids and cometary nuclei. It had structure. There were geometric features visible even in Hubble's images, edges and planes that seemed too straight, too regular to be natural. The object was elongated, with a ratio of length to width of approximately 6:1, making it even more extreme than Oumuamua's already unusual proportions. But where Oumuamua had been relatively smooth in its rotation and appearance, 3I Atlas showed what appeared to be surface features, protrusions, or possibly craters, arranged in patterns that some analysts swore looked artificial. The images were immediately classified, not by NASA, which wanted to share them with the world, but by elements within the intelligence community who had been quietly monitoring the situation. Within the Department of Defense, within the National Reconnaissance Office, analysts were looking at those same images and seeing something that terrified them. They saw an object from another star system, possibly from another civilization, approaching one of our planetary neighbors at precisely the right trajectory to achieve an orbital capture if it slowed down. They saw what could be a vessel, a probe, or something worse. The debate that erupted in the classified briefings was intense. On one side were the scientists, insisting that this was a natural object, that the apparent geometric features could be explained by unusual fracturing and fragmentation, that humanity's tendency to see patterns and intention in random phenomena was leading to unfounded speculation. On the other side were intelligence and military analysts who pointed out that we had now observed 3 interstellar objects in just a few years. Statistically, that seemed unlikely if such objects were rare. What if they weren't rare? What if they were becoming more common? What if someone or something was sending them? The arguments went round and round, but as 3I Atlas drew closer to Mars, as the encounter date approached, a decision was made at the highest levels. The potential risks, however unlikely, were deemed too significant to ignore. If there was even a small possibility that this object was not entirely natural, if there was any chance that its close approach to Mars might trigger some kind of response or activation, then NASA needed to be prepared for scenarios that had never been seriously considered before. And that meant doing something that had never been done in the history of the space program. It meant shutting everything down. The order came through encrypted channels, delivered to the NASA administrator in a briefing so classified that no notes were taken and no recording was made. The message was simple but unprecedented. In the final hours before 3I Atlas's closest approach to Mars, all NASA missions, not just those at Mars, but every spacecraft, every telescope, every active mission across the solar system would enter safe mode. Communications would be maintained at a minimum level, just enough to monitor spacecraft health, but no commands would be sent, no data would be actively collected, and, most importantly, no maneuvers would be executed. Everything would be passive, observational, ready to respond but not provoking any kind of interaction. The justification, as explained in that classified briefing, was based on a principle from SETI, the search for extraterrestrial intelligence. For decades, SETI researchers had debated the wisdom of actively transmitting messages to the stars, wondering if humanity should be broadcasting its presence to the cosmos or remaining quiet and listening. The concern was that any sufficiently advanced civilization that could travel between the stars would be so far beyond us technologically that we would be defenseless against any hostile intent. The same principle, it was argued, applied to 3I Atlas. If this object was in any way artificial, if it was a probe sent by an extraterrestrial intelligence, then the last thing we should do is actively interact with it. We should observe, we should record, but we should not poke the unknown visitor with radar beams and radio transmissions. The scientific community, when they learned of this decision through carefully worded internal memos, was outraged. This was the opportunity of a lifetime being sacrificed to paranoid speculation. The chances that 3I Atlas was anything other than a natural comet were Yes, it looked unusual, but the universe was full of unusual things. We had barely begun to explore the diversity of objects in our own solar system, let alone catalogue what might exist around other stars. To assume that anything we didn't immediately understand must be artificial was the worst kind of anthropocentric thinking. The modern equivalent of ancient cultures interpreting comets as messages from the gods. But the decision was made, and the decision was final. As the encounter date approached, as 3I Atlas closed to within a few million kilometers of Mars, NASA began the carefully choreographed process of putting all of its missions into safe mode. Spacecraft by spacecraft, instrument by instrument, the eyes and ears that humanity had extended throughout the solar system began to close. The James Webb Space Telescope stopped its observations and pointed away from the Sun into a stable configuration. The Hubble Space Telescope locked its aperture door. The twin Voyager spacecraft, the most distant human-made objects still in contact with Earth, sailing through interstellar space themselves at the very edge of the solar system, reduced their transmissions to carrier signals. At Mars, the preparations were even more extensive. The rovers Perseverance and Curiosity were commanded to stop driving, to retract their instruments, and to enter a hibernation mode with only minimal systems active. The InSight lander shut down all of its instruments except for basic housekeeping systems. The orbiters were placed into orientations that minimized their cross-sectional area to the direction from which the comet would approach, reducing the chances of debris impact. Maven and the Mars Reconnaissance Orbiter, normally in constant communication with Earth, would maintain only periodic status beeps, enough to let Mission Control know they were still alive, but nothing more. The global space community watched these preparations with a mixture of awe and confusion. ESA, the European Space Agency, was briefed on NASA's decision and reluctantly agreed to put their ExoMars Trace Gas Orbiter into a similar safe configuration. China's Tianwen mission, which had a rover on the surface and an orbiter in Martian orbit, received similar guidance from CNSA, the China National Space Administration. Even India's Mars Orbiter mission, operating on a shoestring budget but still returning valuable science, was commanded to hunker down and wait out the encounter. But not everyone was cooperative. The private space sector, which had grown enormously in the past decade, operated under different rules. SpaceX had satellites in orbit around Earth and had been planning to launch a communication relay satellite to Mars. The company's founder made public statements dismissing the concerns about 3I Atlas as government overreach and bureaucratic paranoia. Other private companies, seeing an opportunity that NASA was apparently squandering, announced plans to point their own sensors and telescopes at the encounter, to gather data that the government seemed unwilling to collect. This created a diplomatic and legal nightmare. Space is governed by international treaties, primarily the Outer Space Treaty of 1960, which establishes that space is free for exploration by all nations, but that nations are responsible for their private entities' activities in space. If a private American company decided to actively illuminate 3I Atlas with radar or send radio transmissions toward it during its Martian encounter, was NASA responsible? Could they prevent it? Should they prevent it? The lawyers at NASA headquarters worked overtime trying to answer these questions. and the answers were not reassuring. In the end, a compromise was reached. Private entities would be allowed to observe the encounter, but they would be strongly discouraged from any active sensing, any transmission of signals toward 3I, Atlas, or Mars during the close approach. This was presented as a safety measure to avoid electromagnetic interference that might affect the NASA spacecraft emerging from safe mode after the encounter. Most companies agreed, not wanting to be blamed if something went wrong. A few held out, and there was nothing anyone could do to stop them short of jamming their transmissions, which would have been illegal and probably impossible given the distributed nature of modern communications. As the final hours approached, as 3I Atlas became visible in amateur telescopes around the world, a strange mood settled over the space community and the public that had been following the story. There was excitement, certainly. This was a historic moment. A visitor from another star having a close encounter with Mars. Amateur astronomers set up viewing parties. Planetariums held special events, and live streams proliferated online showing telescopic views of the approaching object. But there was also an undercurrent of anxiety, a nameless worry that something could go wrong. The rumors about the object's unusual appearance had leaked despite the classification. Fuzzy images circulated on social media, analyzed and reanalyzed by amateur enthusiasts who claimed to see patterns, structures, even symbols in the pixelated blobs. The conspiracy theories multiplied. Some claimed 3I Atlas was an alien spacecraft coming to Mars to retrieve something, possibly evidence of ancient Martian civilization that NASA had been hiding. Others insisted it was a natural phenomenon, but that the government was using it as a cover for some kind of weapons test or secret mission. Still others claimed the whole thing was a hoax, that 3I Atlas didn't exist at all, and the story was being used to distract from some political scandal or economic crisis. The noise on social media reached deafening levels, making it almost impossible to find reliable information amid the speculation and fabrication. But for the people actually involved, the scientists and engineers who had devoted their careers to exploring space, the hours before the encounter were marked by a strange stillness. Mission control rooms that were normally bustling with activity were eerily quiet. The big screens that usually showed telemetry from multiple spacecraft tracking their health and status were mostly dark. Only a few displays remained active, showing the predicted trajectory of 3I Atlas and the positions of the various Mars missions. Controllers sat at their stations, not because there was anything for them to do, but because they couldn't bear to be anywhere else during this moment. In the hours before the closest approach, the few observations that were being made showed something unexpected. 3I Atlas was brightening, but not in the steady way that comets normally brighten as they approach the sun. Its luminosity was fluctuating, varying by as much as 30% over periods of just a few hours. This could be explained by the object's rotation, different surface areas with different reflectivity being presented to the sun and to our telescopes as it tumbled through space. But the pattern wasn't quite regular enough to fit a simple rotation model. It was as if parts of the object were becoming more or less active, turning on and off. The speculation reached fever pitch. Was this outgassing jets of material being released from the object's surface as ices sublimated in the heat of the sun? That would be normal for a comet, but the pattern was wrong. Cometary jets were usually associated with the sun-facing side of the nucleus, driven by solar heating. The variations in 3I Atlas's brightness didn't correlate with its orientation to the sun. They seemed almost random, or, if not random, then following a pattern that no one could decipher. One researcher, working late in his university office thousands of miles from any NASA facility, noticed something in the data that made his blood run cold. He was analyzing the light curves, the graphs showing how the object's brightness changed over time, and he thought he saw a pattern, not in the overall brightness, but in the rapid fluctuations, the small variations that most people were dismissing as noise. He ran the data through a signal processing algorithm, the same kind used to search for patterns in radio telescope data from SETI observations. And the algorithm found something, not a message, not anything as clear as that, but a statistical anomaly that suggested the fluctuations were not entirely random. There was structure there, hidden in what looked like noise. He tried to publish his findings, to alert the community, but the encounter was too close. There was no time for peer review, no time for the careful verification that science demanded. He sent emails to colleagues, posted preprints online, and tried to get the attention of anyone who would listen. But his claims were drowned out in the tsunami of speculation and noise that had overtaken all discussions of 3I Atlas. Some people seized on his work as proof of their pet theories. Others dismissed it as wishful thinking, seeing patterns where none existed. And in the chaos of those final hours, his careful statistical analysis was lost. Just another voice shouting into the void. Back at Johnson Space Center, the NASA administrator was receiving regular updates in a secure conference room. Intelligence liaisons were present, and the atmosphere was tense. The latest tracking data confirmed that 3I Atlas would pass Mars at a distance of 14,900 kilometers at precisely 6:43 a.m. Eastern Time. That was in just over 8 hours. At that distance, if the object was actively shedding debris, Mars would definitely pass through its coma. The spacecraft in orbit around Mars would be exposed to whatever material the comet was releasing, and there was nothing anyone could do but wait and watch. The decision to execute the final shutdown came at 11 p.m., 45 minutes before the actual blackout. The administrator gave the order, and it was relayed through the communication networks to every NASA facility and every mission. For the next 12 hours, from midnight Eastern Time until noon the following day, all active operations would cease. The spacecraft would be left in their safe configurations, monitoring their own health but accepting no commands from Earth. The communication networks would remain open. Receivers would still be listening, but no transmissions would be sent. NASA would go dark. The reasoning was explained one final time to the assembled personnel. This was a precaution against the unknown. If the close approach of 3I Atlas triggered any kind of electromagnetic event, any surge of particles or radiation that might affect spacecraft systems, the last thing they wanted was for those spacecraft to be in the middle of executing commands from Earth. Complex operations required complex command sequences, and if those sequences were interrupted by interference, the results could be catastrophic. Better to have everything in a simple, stable, passive state. Better to let the spacecraft wait out whatever was going to happen and then assess the situation afterward. It made sense from an engineering standpoint, but everyone in that room knew there was another reason, the unspoken reason. If 3I Atlas was something other than a natural comet, if it reacted to the presence of active sensors and transmissions, if it did something that no one could predict, then humanity's response needed to be measured and coordinated. They couldn't have individual missions, individual operators, making split-second decisions that might have consequences for all of humanity. Everything needed to go through the proper channels, the proper chain of command, And for that to happen, for those crucial first hours, they needed to have nothing happening at all. As the clock ticked toward midnight, as the final minutes of normal operations counted down, technicians performed last-minute checks on all systems. The spacecraft were as safe as they could be made. The telemetry was flowing normally. Everything looked good, but there was a palpable sense of dread in the air, a feeling that they were crossing a threshold into unknown territory. For the first time in over 60 years, since the earliest days of the space program, NASA was going to intentionally stop flying its missions. They were going to close their eyes, cover their ears, and wait for the storm to pass. At 11:47 p.m., 13 minutes ahead of schedule, the shutdown began. Later investigations would puzzle over why it happened early, whether it was a miscommunication, a timing error, or something else. But in that moment, no one questioned it. The screens went dark. The telemetry stopped flowing. The constant background noise of a working mission control, the sounds that had been a part of these buildings for decades, suddenly ceased. And in the silence that followed, the people gathered in those rooms. The people who had devoted their lives to exploring space, to pushing the boundaries of human knowledge, sat in the darkness and waited for dawn, waited to see what an interstellar visitor would do when it reached Mars. Outside the NASA facilities, the world continued. News networks ran countdown clocks to the closest approach. Amateur astronomers trained their telescopes on Mars, hoping to catch a glimpse of something historic. Social media buzzed with speculation and excitement. But inside NASA, inside the heart of the American space program, there was only silence and darkness and the terrible weight of not knowing what the next 12 hours would bring. They had made their choice, had taken their precautions, and now all they could do was wait. Wait and hope that when they turned everything back on, when they emerged from this self-imposed blackout, the universe would still make sense, the laws of physics would still apply, and the unknown visitor from beyond the stars would have revealed itself to be nothing more than a chunk of ice and rock, a natural object following natural laws, indifferent to the fears and hopes of the tiny beings, watching its passage from a small blue world farther from the sun. But hope and certainty are very different things, and in those dark hours, certainty was in very short supply.